Okay, so Jupyter Notebook is a notebook where you write Python codes, and Google Colab is a type of that notebook that lives on the cloud, and that's what we'll be using because everybody has different machines and installations might cause a problem. That is why we are using the Jupyter Notebook. And Google Colab makes it easy because most of the modules we're using are already pre-installed. So to go to Colab, you just have to open your browser and type Colab, just the Colab that you are seeing, COLAB, and hit enter. Okay, so when you hit enter, this is what you get. The very first link is what we are looking for. So welcome to Colab. You click on it and then it will send you to the Colab page. All of this, since it's on the cloud, you need to be connected to the internet. So with this interface, all you have to do is to click on new notebook below here, and a new Jupyter notebook file will be created for you. Because you are using Google account, all your Jupyter files will be saved to your Google Drive. So this is the main interface of the Colab. There are two types of cells. The cells is where you type your codes. There is the code cell and also there is a text cell. To add a code cell or a text cell, you use the two buttons at the top here or the two buttons below the active cell. So the code cell is where you are going to type the Python codes, and to run the code, all you have to do is to click the play button beside the cell. The text cell is just a normal cell that takes normal text. It's for documenting your code. So anything you type there will be rendered and inputted. It's not a code, it's just a text to document your notebook. That's why it's called a notebook. Okay, so that is a brief introduction to it. As you move on, you get to know some parts of it. Okay, so we'll be starting here, and I hope my voice is clear and everybody can see my screen before I begin. Okay, all right. So most of the things they are seeing here, they are just text cells. So these are just things for me to use to um, teach you what we have for today. So before we begin, we are going to start with a question. I'm sure everybody here has a mathematical background, so and most of the concepts I will still explain them, so you don't have to worry. So the question here is to calculate the current through a wire that has a resistance of 11 ohms and a voltage of 230 volts. So the law or the equation that we use to calculate this type of things is called the Ohm's law, and this is what it is: V equals IR. So the computer is, like the name suggests, it's a calculator. So the computer is calculator computing. So we can type the Python code here to calculate the current through this wire. So if you know your math to make the change of subject here, you know that the current will just be the voltage divided by the resistance. So you can type the value of the voltage and then find the quotient of the voltage and also the resistance. So Python supports the four operations that we have: addition, subtraction, multiplication, and division. So when you do that and you run it, we should have um, the value of our current. So as simple as that. This is to make you understand and to build the understanding of the four operations that Python supports. Okay, so the numbers that we just typed here, they are what we call data. And the data that we use in Python have types. We have these two numbers here, what we call integer data types. An integer is just a whole number without any decimal or fractional part. So the 230 and 11 are both integers. The answer that we got is a decimal. in Python, the term for decimal is floating point. So that those are the all that I've said are just what has been put here in those four bullet points. Okay, I hope that is clear. There are two data types, the integer data type and also the floating point data type. For now, any question with this? Is everybody okay?
No, please, please, can you explain the integer and the floating again? The
Okay.
data.
So the numbers we just use are for the questions that we are trying to solve. So the to calculate the current is the voltage divided by the resistance. Um, the voltage value is 230 and the resistance is 11. 230 is an integer because integers are whole numbers. Whole numbers are numbers without any decimal or fractional parts. So 230 is a whole number. 11 also is also a whole number. So these two numbers are what we call integers. The answer that we have has a decimal part, so that's what we call a floating point number. So those are the two types of data that we just dealt with. We dealt with an integer number, and also we have a decimal point, which is also called a floating point number. So whole numbers are integers, and then decimals are called floating points. Is that okay? Or you are still foggy on it?
No, please, please, I'm okay.
Okay.
Thank you very
Yeah,
much.
please again. I like how some of you interrupt us. You need to understand this before we move on. Because as we move on, it starts to get more and more complex. If there's any part you don't understand, you can type the questions in the chat, or you can unmute yourself and then you ask me. Okay, so this is a very simple calculation that we just did using Python, just using numbers and division signs. So is that easy? Another question we have here is a bit um, a lot, but as we solve, you'll get to understand it. So three beds. This is what we are calling the three beds. So one, two, three. Three beds with equal width and length. So the width and the length of these three beds is 5,000 centimeters, and they are subjected to flow. We are flowing a fluid through these three beds. That's why you are seeing the Q1, Q2, and the Q3. So three flows are passing through these three beds. Think of it like three sands packed on top of each other, and we are trying to flow a fluid through this sand. Okay, so we are supposed to find the permeability of this system. The permeability, the name of the as the name suggests, permeability. So how permeable the system is, um, how much the system allows fluid to pass through it. That's what we call the permeability. The permeability of the system can be calculated by the equation that you are seeing here. Again, for those who are not really into math or um, who don't understand what this equation means is, if we know the permeability for each bed, so there's bed 1, bed 2, and bed 3, and we also know the height of each bed, we can find the product of the permeability and the height of each bed, and then we find the sum of all the three beds that we have. So that's what this equation means. So multiply the permeability and then the height of each bed, and then find the sum. That's what this symbol that looks like an M means. Then we find the total height of all the beds. If you do that, we can find the permeability of the entire system. So that's just what it means by calculating permeability of the system. All we have to do is to multiply the permeability of each bed by the height of each bed. We do that three times and we find the sum. Okay, so let's do that first. So that's the same equation that I'm repeating here. Okay, so to do that, you just have to know the numbers that were provided. The permeabilities and then also the thickness have all been provided. So the first one is 1000. That is the thickness of this bed times the 50. So this is the thickness and also the permeability of bed 1. These are the values. So you just have to multiply them and then you find the sum of each bed. So this is for bed 2. And this is for bed 3. So this is just what we have. That's exactly what the equation at the top here means. Multiply the permeability and the height of each bed and then find the sum of the other ones. Okay. Then after doing that, you just divide the entire summation by the sum of all the heights. So we divide that by the sum of all the heights, which is 1000 plus 1500 and then the 5000. So I like to use brackets so that you can see what is happening. And also I'm going to put the entire numerator inside brackets. So then we can differentiate the numerator from the denominator. All of this is just for you to have a feel of the operations that we have. So this is the formula that we
It's
just used.
you went out and you knew by the water.
Right, so we can run this and then we have our average permeability of the entire system. So this equation is what we just solved here. Anybody has any question? Is that okay?
Yes, please.
Okay. So it will be better if you unmute and speak. The I will have to be switching to see your messages. So because I don't want to be switching, it will be better if you could unmute and speak if you have um, anything to say. Okay, so we just calculated the permeability. Now that was just one part of the question. Now we need to calculate the flow rate of the fluid passing through these three beds, and the equation is what we have here. So it depends on the permeability that we just calculated and other parameters that have been provided um, in the question. So we need the relative permeability that we just found. We need the area, so the cross-sectional area of where the fluid is passing through, and we need the pressure P1 here and the pressure P2 here. All those parameters have been provided here. So we just have to key in those values and we can find um, the, the flow rate through the system. So we start by typing, yes, your hands is up. I am Montel Abraham.
Yeah. So I wanted to ask that the permeability. I know that permeability is like it has like a direction. So it's because the flow is horizontal. That's why I use that formula for the permeability. The
Yeah,
average permeability.
yes. So I don't want you to be worried about the direction or anything here. Just be concerned about how we can use Python to solve the question. Don't worry about the technicalities of the equation. So don't worry
Okay,
about it.
okay, okay,
Yeah.
okay.
Okay. So and also here is supposed to be negative. All right, so we start putting in the value. So negative 0.001127. Then our relative permeability that we just calculated here is 400 times the area of the cross-sectional area of the flow. So the area of um, the cross-section was not given explicitly. We needed to calculate that ourselves. So we know the width and we also know the height. So we just have to find that the width is 5,000 centimeters, and then the height is the summation of the height of the individual beds. So I'm going to put that in brackets so that it will be visible. So this is going to be for the area. The width is 5,000, and also the height is going to be the h1, the h2, and the h3. This is what is given here. So we have to add all of this up to get the height of the total bed. Because I don't want to use my head, I'm just going to type that in. But if you can add that in your head, you can do that. So 1,000, 1,500. So I think that should be 1,000 plus 1,500 and then 5,000. Okay, so what I just highlighted here is the area here. So the width is the 5,000, and then the total height is the sum of the heights of the individual bits. So with that done, we multiply that with the pressure differences, and the pressure that was given here. So the 990, um, and then the P1 is the 2,000. And also sometimes when you are typing, you see that the Gemini AI that is part of the Colab can be giving you code completions. So when you like that, you can commit it by hitting the tab key on your keyboard. Okay, so we just did the numerator part, and now we can just divide all that by the product of the viscosity and also the length. So the viscosity is 2, and then the length is the 5,000. Okay, so is everybody okay with this? Basically, we are just substituting values for the equation that we have here. This is normal thing that you usually do on your calculators. I hope this is fine.
Please, I'm not seeing your.
Sorry,
I'm not seeing your screen.
does everybody have the same problem? You can't see my screen.
No, please, I can see your screen.
Okay, I think you should refresh, or maybe you should go and come back. I don't know, maybe it's your internet connection, so please check.
All right.
Okay,
Um,
okay, so we did that. It's back.
Geez, what the hell? Yeah, it's back.
Okay, so the things that we just did are things that we do normally using the normal calculators that we have. But we are learning programming because, and most of the manual things that we just did here, we are not supposed to be doing this. So that's why we are learning programming, or Python to be specific. So we are going to resolve this question using some of the capabilities of Python. So we are going to redo that, and this way of using Python is not actually encouraged. If your calculations that you are going to do are going to be voluminous, this is going to be very difficult to do. And some parts of the code, we have to copy the values that we calculated and paste it ourselves. We are not supposed to be doing that with Python. So we are going to resolve the question again, and by using um, the first concept, what we call variables. So instead of hard coding the values ourselves, we are going to um, add variables to these values on our computer memory. So um, we are going to store these values in memory and assign variable names to them. So this is the first height. We are saying that we are adding this variable name to this value. So every time we want to use the height of the first bed, we will call the h1 variable name. So I'm going to do that for the other beds as well. So h1, h2, and h3. So these are the heights of the three beds. So when we are using variables, when we are going to solve this equation now, we will not be using the actual values, but we'll be using the variable names instead. So let's do that for the permeabilities also. This is 50. Okay, so with that, we have the values stored. Um, I don't know. Uh, Now we can do this same calculation again by using the variable names. So we have k1 times h1. I like to put this in brackets so that it helps with documentation, and I can have the rest. So we have k2 times h2, k3 times h3, and then divided by the sum of each of the heights. So that's why we have h1, h2, and h3. So you see that this helps. This is far more readable than the first one that we did. So this is going to be a value. This entire computation that we did here is going to be a value. So when you run this, you will see the value that we have. And this is what I'm saying. The value we have here is different from the value that we got from the previous calculation. This is because we have not bracketed our numerator well. So it is now dividing the last operation instead of dividing the entire numerator. So we put the entire numerator in brackets so that the separation can be well seen. So we run that again, and then we have the 400 that we got before. So the extra bracket that I added is to show that this entire thing is 1 unit, then divided by the numerator. So we can store this value also inside a variable. So I'm going to call that average permeability. So when you do this and you run it, you'll not get any output because we are calculating the value and then we are storing it with the variable name k average. So there's nothing to output. If you wanted to output this, you just use the print function that we learned, and then you will see the value. Is this okay? All right.
Yes, please.
So the variables, we are assigning names. We are basically assigning names to these values, and then we'll then use those values. I'm sorry, those names in computations instead of the values themselves. So this is where this is going to be very helpful. So now we have to calculate this flow rate. We don't have to memorize what the K average is. We just have to know use the name of the K average in the calculation, and then we'll continue. But we are still going to give variable names.
Please, I want to ask a question.
Yes,
Please, the moment you define the variables in the code cells, does it mean that you can use them in different cells on your
yes,
notebook?
yes.
Okay.
That's a very good question. So when you define a particular variable, you can use it in any cell in the particular notebook that you're working in. So you can use this same h1 or whatever variable that you defined in other cells in this particular notebook.
Yes, please. Thank you very much.
Yeah. So now let's define the variables for the other parameters. So we need the value for a, we need the value for p1, we need the value for p2, we need the value for um, this this symbol is called mu. So I'm just going to call it as mu, and we need the value for the length. So in the question we have w as well, so for the width. So the
Please, I have a question.
please go ahead.
All right, so the Q is equal to minus 0.00 blah blah blah. That is a formula for finding something.
Yes.
Oh, okay, all
So
right.
we
I
are
was a
trying
bit
to find
confused.
that formula. We are trying to find q, and q is equal to that formula.
All right, okay, all right. Thank you.
So the width is 5,000 centimeters. The area is the width times the height. So the height is going to be h1 plus h2 plus h3. So if you don't know why I'm doing this, the cross-sectional area here is the width times the height, and the height is the sum of h1, h2, and h3. And we already defined what h1, h2, and h3 are going to be, so we can use that since we already defined them here. So that will be for our area. The P1 and the P2 are also given in the question. So P1 is 2000, P2 is 1990. And then the mu is 2, and also the length is also 5000 centimeters. So now we can find Q by using the values, um, the equation that we have. So then we then divide all of these by the mu times the L. Then we can print Q. Okay, so is everybody okay with this? Again, if you have any questions, please ask.
I wanted to ask some question.
Yes,
Please, when we use the calculator method, typing it raw in as it is, like typing the
the
figures,
values here.
not yet they are defining the variables.
Yeah,
I realized that we had a negative value.
the negative value.
Yes, a negative.
Yeah,
Yes, we had a negative value, even though in flow rates, that negative sign shows that pressure is moving from a higher to a lower like region.
yeah.
Even though that doesn't matter, I don't understand why when we define the variables, it
Hmm.
was positive with a negative value. But when we calculated it raw as it is, we had a negative value.
Okay, so what we did here was so the equation was supposed to be p2 minus p1. Okay, and the value for p2 is actually the 990, and then the p1 is the 2000. So when you do that, it will be positive. We made a mistake here. Do you get what I mean?
Please, yes, please.
Yeah,
I've seen where the mistake is coming from.
yeah. So most of you guys are petroleum engineers, so you are very particular about the equation. Again,
Yes, please.
that is fine, but as long as you understand what we are doing, I'm happy with that. All right. So we've understand we've just went through what variables are and what data types we deal with. So far, we've dealt with integers and also floats. And also there are some other um, data that we deal with in Python. It's not just integers and floats. So there are, I'm going to introduce you to two other data types, what we call the string data type. So for example, this is what we call a string, or what we call characters. So we can also store characters and assign variable names to them. To store characters, they have to be in between quotation marks, either single quotation marks or double quotation marks. Because if you remember, when we were learning about the print statement, we had to put the message that we wanted to print in between quotation marks. So if you are going to be dealing with text or characters, you always have to put them inside either double quotation marks or single quotation marks. So to deal with strings, this is what we we use. So this is what we call a string. So characters are called strings in Python. Can go ahead and print this name, and we should have the name printed out. So now, if we wanted to,
Hello,
yes, I'm listening.
please, I have a question.
Yeah,
You were saying that the print, formally the print, you have to, with whatever you want to print out, you have to put it in a quotation marks.
if
Uh,
the message you are trying to print out, if it is a string, it has to be in between quotation marks. A string, what if I say a string, I mean characters or sentences. Yeah, so go ahead.
yeah, so you saw that with the first one, like print hello something, you
Yeah,
put it quotation mark, but with this time print name, no quotation mark. So
yeah,
I'm trying
okay,
to understand why.
okay. So this name here is the name of the is the variable name of this data here, or of this value here. The variable name itself doesn't have to be in between quotation marks. So you saw that when we were trying to print the value of q, we didn't put it in between quotation mark. If we put q in between quotation mark, what we will print is the string itself, the q itself. So all that we'll get is q, not the value of, q. Again, variable names are just pointers. So if you try to print a pointer, it will only print the value to which it is pointing to. So if I'm trying to print q, q itself is not stored in memory. Q is just a pointer to the value that we have in our memory. So if I'm trying to print q and I just typed q here, all that I'll get is the value that q is pointing to. But if I want to print the sentence itself, I'll have to put that in between quotation mark. So the name here is a variable name, or a variable name is a pointer. And if you are trying to print the value to which the pointer is pointing to, you just use the name as it is. But if you want to print the string itself, it has to be in between quotation marks.
Okay, please. Thank you.
Okay. So if I did this, all that I'll get is name. But if I, because the coffee here in memory has a pointer, you have to, all we'll get is the coffee. Okay. All right. So there is a difference between something like this and something like this. So Python sees this as a string. Anything in between quotation marks, Python sees it as a string. And if a number that is not in between quotation marks, Python sees it as it is. So this is going to be an integer. So that the Python sees these two entities as two different data types. That is just one distinction I wanted to make. So if I wanted to store the time of day in memory or to assign a variable to it, so let's say the time is 12:30. This is what I'm going to do because there's no number that says 12:30 like this. There's no real number that looks like this. That number has to be in between quotation marks, and we'll report this as a string, not a real number. Okay. I hope this is clear.
Yes, please.
Yeah. Now, we can also store full sentences as strings. So whether I use spaces or not, Python counts the spaces in between characters as also a character. So you can concatenate variables together, and as long as they are in between quotation marks, Python will see that as a string. Please, is that okay?
Please, can you go over that again?
Okay, so um, let's say we have first name. We are trying to store first name in memory, and then say last name. Or let's now we would like to store full name. So I'm going to say, so what I'm trying to say is that this entire thing here, Python sees it as a string. Although there's a space between it, Python counts the space also as another string. So the entire thing here in between the quotation mark is a string to Python. Anything in between either double or single quotation mark is a string. That is what I mean. Please, is that clear?
Yes, please. Thank you very much.
Okay. So I'm sure you can see that I have some
Please, I
numbers.
have a question.
Yes, please go ahead.
Okay, so from what you are saying, that when once you introduce the quotation mark, it means everything in between is seen as a string.
Yes.
Let's say for the coffee, the space and then the pen. Let's say I don't put anything there, like it's just the quotation and there is no character inside. And if I print it, is there going to be a feedback?
So
I
something
don't know
like
if
something like this. If I take off the space between the coffee and the pen and I try to print it,
no, like taking the coffee and the pen from then just leaving a space.
okay. So then I print what we have in the full name. Something like this.
Exactly.
Yeah. So because there's nothing in between, you will not get although there is something here, there's a space here, but because the space you can't see it, Python is printing just the space that we have.
Okay, okay.
Yeah. So whatever goes in here is what will be printed, and if there's nothing in there, nothing will be printed as well.
So this, please, this is the same as like defining your strings, right?
Yes.
All right. Thank you.
Okay. All right. So another thing you should notice is that giving variable names has some rules. So you can't start a variable name with a number. So if you are giving a variable name and then you start with a number, that is one of the violations you are striking. Another thing is you can't start a variable name with most of the symbols that you have on your keyboard. So the exclamation sign, the @ sign, the dollar sign, you can't use that. The only character that is allowed is the underscore. So that's the only one that you can use. And also, you can't use a reserved keyword as a variable name. What I mean by reserved keyword is a name like print. Because print is a function in Python, you can't use that as a variable name. So those are the three rules that you should adhere to if you are giving variable names. You can't start with a number, you can't use special symbols, and also you can't use reserved keywords. Okay. So we are going to talk about the last variable, the last data type in Python, and that will be it for today. And you'll be giving this exercise to solve and sending screenshots of it into the group. Okay, so suppose we have age to be equal to, let's say, 19, and we want to check if this age, or if this the value that age is pointing to is greater than 180. So what we get is a for statement. So what this means is that Python has two reserved keywords, true and false. These are what we call conditional data types, but in Python we call them Boolean data types, or Booleans. So this condition here, age greater than 180, the value for age greater than 180 is false. So the data type of this expression here is a Boolean. I'm going to say that again. The value here, 19, has a data type of integer, and the expression here, because this is not equal to, we are not assigning anything, this is an expression. The value of this expression is a Boolean. We are checking if age is greater than 180. And the answer that we get is false, because indeed the age is 19. So age being greater than 19 is a false statement. So this is the last data type. We don't really talk about Boolean so much, but as we move on, you will get to understand its purpose in programming. So the character that we have here is what we call a conditional operator, and there are other conditional operators. As long as we have greater than, we also have less than, greater than or equal to, less than or equal to or not equal to. These are mostly the common ones that we'll be using throughout. So one last function. We learned about the print function. Now we are going to talk about one last function that we normally use. It's called the type function. If you wanted to know the type of data stored in any variable, we just use the type function. So if I put this variable name age here, and I want to know the type of data stored in age, if I use type, I will see that I have int, which is short for integer. If I can also check the type of data type stored in the average variability that we calculated, and we'll see that it's a floating point data. So this type function is very good sometimes if you don't know the type of variable that you have in your system. Okay, so that is it for today. We've learned about variables, we've learned about data types, and we've learned about variable names and also the rules. So we calculated this exercise using the raw numbers that we did. So now that you know about variables and also about operations, redo the exercise that we did previously and send your answers into the group. Okay, so that is it for today.